All right, starting lesson 6.6, congruence and similarity. So what's the difference? Okay, because often students confuse the two. So this chart that we have here breaks it all down. So congruence. Here's the symbol for congruence, the equal sign with the squiggly line above it. All right, here's our congruence statement. And when two triangles are congruent, you know that all of the angles are congruent and all of the corresponding sides are congruent. Now, how is that different from similarity? All right, for similarity, here's a symbol for similarity. It's just the squiggly line. Here's a similarity statement. And now for similar triangles, you know that all the corresponding angles are congruent. But for the sides, you know that the sides are proportional, meaning all the ratios of the corresponding sides are equal. Okay? Now they could be congruent, but they don't have to be. As long as the ratios are equal to each other, then the sides are proportional and the triangles will be similar. All right, let's go through some questions that test your understanding between congruence and similarity. All right, example 1. Determine if the triangles are congruent, similar, both, or neither. All right, so looking at part A here. All right, I know that all of the angles, corresponding angles are congruent. Okay. And then let's see, what else do I have here? I know that they're similar, just based off of that alone, because remember the shortcut AA? Now, are the triangles congruent? Well, this triangle has a side length of 4. Does this one? No. So right away, not all the sides are congruent, so the triangles can't be congruent. But I do know that they're similar just by AA alone. You could take the ratios of all the corresponding sides, and you could verify that they're equal. All right, so these two triangles are just similar. For part B, all right, let's look at these triangles. I have all the corresponding angles are congruent. All right, so right away I know that they're similar. Okay, that's just by the shortcut AA. Now let's look at the sides. All right, I have 2 here, 2 there, 4 here, 4 there, 2 square root of 3 here, 2 square root of 3 there. All right, so they're also congruent. All right, so the answer is both. All right, and if you took the ratio of all the corresponding sides, you notice that they're equal to 1. So if two triangles are congruent, their ratios, the ratios of the corresponding sides, are always equal to 1. Just a little side note. All right, for part C, let's see what we have here. I have 73. I have 53. There's no 53 for C. So right away, I know that neither is true. Okay, because for congruence, all the angles have to be congruent. For similarity, all the angles have to be congruent. All right, and there's an important idea on the bottom here. If two similar triangles have a ratio of 1 to 1, then they are also what? If they're similar and they have a ratio of 1 to 1, then they are also congruent. All right, an example of that is just like what we see up here in part B. All right, let's do some more examples. Determine if the statement is always, sometimes, or never true. Note, drawing diagrams can help you determine the correct answer. All right, for part A, if two triangles are similar, then they are congruent. All right, here's two similar triangles. Let's do something like that. All right, I got these angles are congruent. All right. Now the angles are the same, but are the side lengths the same? No. So if two triangles are similar, then they are congruent. Well, I could have this situation too. I could have this. Okay, now if I have this situation, these triangles are similar and they're congruent because all the sides are the same length. So for part A, the answer is sometimes. And touching on the idea before, if the ratio of the corresponding sides is 1 to 1, then the triangles are congruent. For part B, if two triangles are congruent, then they are similar. Okay. If they're congruent, that means all the corresponding angles are congruent and all the corresponding sides are congruent. Okay? Then they are similar. All right? This is always true. All right, if two triangles are congruent, then they have to be similar. And the ratio of the corresponding sides would be automatically 1 to 1. For part C, it says if two triangles are congruent, then they are not similar. Well, that's just the opposite of what we have for B. All right, so if part B is always true, then part C would be never. It's just the opposite idea. All right, let's do some more examples. All right, which triangles must be similar? Two obtuse triangles. All right, well, can you come up with two obtuse triangles that are not similar? All right, so for part A, let's see here. I have a triangle that's obtuse, that's 100 degrees. And another obtuse triangle, that's 101 degrees. Okay, not all the angles are the same, so right away they can't be similar. So that's off of the options list. Two scalene triangles with congruent bases. Scalene triangles with congruent bases. Okay, so here's the base. This is my scalene triangle. All right, here's another base. And then I'll do something like that. That's another scalene triangle. Remember, scalene means none of the sides are the same length. All right, well, right away you look at this, and these two triangles are definitely not congruent. And if you just look at the shape of them, right away you'll be able to tell that they're not similar. Look at the angles. The angles are definitely not the same, so they can't be similar. All right, that's just a counter example there. So that shows that choice B will not work. Two right triangles. All right, well, here's a right triangle. And here's another right triangle. I could say that this is 30, this is 60. I could say that's 45, that's 45. All right, here I have two right triangles. Are they similar? No, the angles aren't the same. So by process of elimination, we could just say that D is correct, but let's verify that. So two isosceles triangles. Okay, with congruent vertex angles. Okay, so I have two isosceles triangles. All right. This is the vertex angle up here. All right, well, what do you know? Let's just say this is 30. And that's 30. Well, if I want to figure out the base angles, I subtract 30 from 180. I get 150, and I divide that by 2. So I get 75. So these would be 75. All right, and right away by the shortcut AA, I know that they're similar. Okay, and it doesn't matter what the side lengths are. All right, the ratio of the corresponding sides will still be equal. All right, but the big idea here is that I'm able to show that they're similar by the AA shortcut. All right, so D is my correct answer. And last question here. Which of the following best describes the triangles shown below? This triangle got cut off. All right. Okay, so both are similar and congruent. Well, let's see. That's 60, that's 90, that's 30, that's 30, that's 90, that's 60. Okay, right away, just based off the angles alone, I know that they're similar. And here I have one pair of sides to work with. And if I take the ratio of those pairs of sides, I get 1. Okay, now if two triangles are similar and the ratio of their corresponding sides is equal to 1, you know that they're also congruent. Okay, so just based off the angle measures, I could say that they're similar. Now, based off the fact that the ratio of the corresponding sides, the ratio of the hypotenuses, is equal to 1, I know that they're also congruent. So the answer is A. Okay, that's all there is to it. Hopefully this helps you understand the difference between similarity and congruence. If there's any confusion, if you have any questions, please make sure to ask for help. Begin the assignment.